Hi, today we are going to take a focused look at one of the most fundamental and critical aspects when selecting a large language model for any generative AI application: performance and accuracy. At its core, an LLM needs to work, and it needs to work exceptionally well for your specific needs. This isn't just about picking a popular model. It's about making an informed choice that directly impacts your application success and user satisfaction. Let's explore how we ensure that. Our first and perhaps most crucial consideration is task alignment. It's not enough for a generative AI model to be generally good. It needs to be excellent at your precise use case. Think about it. The characteristics you need for generating text are vastly different from those required for creating images or videos. For text based applications, if your goal is summarization, you will prioritize models known for factual accuracy and conciseness. For code generation, you need syntax accuracy and logical flow. And for creative writing, fluency and imaginative output are key. But generative AI extends beyond text. If you are working with image generation, you will be looking for models that excel in specific areas like artistic style, photorealism, or maintaining object consistency across different prompts. For video generation, the demands become even more complex, requiring models that can ensure temporal consistency, smooth motion realism, and overall coherence across frames. The key here is to avoid the one size fits all trap. While a generalist model might handle many tasks adequately, a specialist model designed or fine tuned for a particular domain, be it text, image, or video, will almost always deliver superior performance for that specific task. Understanding your task's unique demands is the first step to picking the right AI brain. This brings us to model size and capabilities, where the common misconception is that bigger is always better. While indeed larger models like the latest iterations of GPT possess incredibly broad general knowledge and impressive zero shot capabilities across diverse tasks, they come with significant trade offs. These include substantially higher inference costs, slower response times due to their complexity, and a much larger computational footprint, especially if you consider self hosting. For many specific applications, particularly within a corporate environment, the power of smaller, more specialized models cannot be overstated. Think of models like Llama's 3's 8 billion parameter variant or Mistral models. These can be incredibly efficient, and when properly fine tuned with your proprietary data, can often outperform a massive generalist model for a niche task. The benefits are compelling: lower latency, reduced operational costs, and often easier deployment within your existing infrastructure. So the choice isn't just about raw size, it's about intelligently balancing a model's broad understanding with the focused expertise your application truly needs. Don't hesitate to explore fine tuning smaller, more agile models to achieve optimal performance and efficiency. Now, how do we actually know if an LLM is performing well? This is where evaluation metrics become indispensable. It's absolutely crucial to define your success criteria before you even start choosing a model. What does good output look like for your specific application? We typically use a combination of quantitative and qualitative approaches. Quantitative metrics provide objective, measurable ways to compare models and track progress. For tasks like summarization or machine translation, metrics like BLUE and Rouge measure the overlap of words and phrases between the model's output and the human written reference. Meteor is a more advanced metric that also considers synonyms and paraphrases. For classification or information extraction tasks, the F1 score is a common choice, balancing precision and recall. These metrics are vital for benchmarking and showing tangible improvements. However, LLMs are complex and numbers alone don't tell the whole story. This is where qualitative metrics come in. Human evaluation. Where does experts assess the model's output for relevance, coherence, tone, and safety is often essential for nuanced quality. Gathering direct user feedback is also invaluable. A critical aspect of accuracy often missed by purely quantitative metrics is hallucination. How often does the model confidently present false information as fact? Your evaluation framework must explicitly address this. A robust evaluation strategy combines both objective and subjective measures to give you a complete picture of performance. Finally, let's consider latency, the speed at which your LLM responds. This isn't just a technical detail, it profoundly impacts both user experience and your system's overall efficiency. For real time applications such as conversational chatbots, interactive assistants, or live content generation, near instantaneous responses are absolutely critical. Even a delay of a few seconds can lead to user frustration, disengagement, and ultimately abandonment of your application. Users expect modern AI tools to be responsive. On the other hand, for tasks like generating daily reports, processing large batches of text overnight, or offline content moderation, a slightly higher latency might be perfectly acceptable. However, even in these scenarios, latency still impacts your system's throughput and the efficient utilization of your computing resources. Several factors influence latency: the size and complexity of the model itself, the underlying hardware it runs on, GPUs versus CPUs, network conditions if you are using an API, and even batching strategies, processing multiple requests simultaneously. To mitigate high latency, you can look at using smaller, more optimized models, employing techniques like quantization to reduce model precision without significant performance loss, leveraging efficient inference frameworks, and implementing caching for frequently requested outputs. Understanding these response time requirements is vital for both user satisfaction and cost effective operation. To quickly summarize our deep dive into performance and accuracy, here is a checklist for you. First, always align the LLM to your specific task. Don't just pick a popular generalist. Find the model that truly excels at your particular problem, whether it's text, image, or video. Second, look beyond raw size. Smaller specialized models often offer superior performance and efficiency for niche applications. Third, define success objectively by establishing clear, measurable evaluation metrics before you make your choice. Fourth, match the speed to your need, carefully considering the latency requirements of your application. And finally, always be mindful of and actively work to address hallucination. It's a critical accuracy concern for all LLMs. By focusing on these points, you will be well on your way to selecting an LLM that not only performs but performs accurately and efficiently for your generative AI application. If you like this content, please like, share, comment, and subscribe for similar content in the future. See you in another video. Until then, elevate.